Great to have you this afternoon. My name is John Heyman. I'm going to be chairing the session on Automaton. It's my pleasure to introduce Jeremy Warner. Jeremy is the chief scientist at DOT&E. He has an extensive career. He's worked, currently at DOT&E, but also in the past at IDA and Johns Hopkins APL. He comes, his education, he has a PhD in physics from Princeton. Very impressive background. Jeremy is going to be speaking to us today about Automaton, which is a general intelligence data platform that he and his colleagues developed. So I'm looking forward to this session because I expect to learn something new. So let's welcome our speaker. And hand it over to Jeremy.
Sure.
So,
all right. So, thank you for that really kind, generous introduction. Yeah, I'm Jeremy Werner, DOT&E's chief scientist, and as I think you all know, one of our strategic thrusts within DOT&E, but also one of the department's strategic thrusts, is creating data advantage, right? And that means making data not only accessible, but accelerating the process of converting data to actionable insights that can be used for decisions, right? So accelerating decision times is one thing. Providing leadership at all levels the access to the data they need and the means to quickly convert that data into actionable again insights for decisions, right? Now it goes more than that though, right? Because one of DOT&E's strategic thrusts also involves preparing us for the test and evaluation of future joint warfighting concepts, moving from a notion where in the past where we're looking at a system and seeing how well it does its mission, to we're looking at a group of systems and we're looking at the con-ops of how that group of systems operates across multiple domains, right? And so to elucidate high-level mission effects, right, when you have a heterogeneous systems and warfighting domains requires a new level of rigor and discipline and analysis, right? To glean those mission level effects and to capture the synergistic effects, the emergent behaviors that we would expect of modern joint future warfighting operations, right, and concepts. So I built this platform along with some other folks while I was employed by Johns Hopkins University Applied Physics Laboratory. They were kind enough to give it to the federal government when I joined the federal government. So completely unrestricted. I'm going to show you how I like to operate on data, right? And I'm going to run through 3 different data sets really quickly, generate full analysis of them for exploration purposes, and with full data drill down, interactive charts, all kinds of kind of bells and whistles, if you will. And I'm going to show you how I can do that really rapidly. And with this platform, you can take data sets that you might have and likewise feed them into this platform and generate an exploratory analysis just as quickly as I'm going to show here today. And also, although I've mentioned exploratory analysis several times, this platform also allows you to it's extendable, right? So you can extend it with your own algorithms of any level of complexity in either R project or Python. And if there's a desire to extend it to MATLAB, that's something that I'm happy to discuss as well. Sorry, that was kind of long-winded. Let's just let this thing run. So, I already have it set up, so it's asking me a question. would you like to run Automaton? It's going to automatically find the data sets. And by the way, the first 30 minutes of this, or 40 minutes or so, it's intended for action officers, senior leaders, as a capabilities demonstration, so they can see how quickly this platform allows or enables rapid data analysis. And then for the remainder of the time, the session is for hands-on time with technical practitioners who are interested in getting this platform up and running on their machine. The prerequisite is a Windows subsystem for Linux or another Unix environment like Mac iOS. But anyway, so first part of the session is for action officers, senior leaders. Second part, technical practitioners. Okay, so having said that, I'm gonna push the button here and let it run. You're gonna quickly see that my machine has 16 different CPU cores. They're rapidly going to all come to life here. You don't need to focus on what this is doing, what this screen is showing, except that you're going to rapidly see, 0 through 15 CPU come to life. And you can see Automaton is running. Okay, it's telling you that it's going after the first data set called Iris, and the second data set is called MPG, and the third data set is called Sea Creatures. We'll let it continue to run, and let's take a look at what this data set looks like. In particular, oh, see, it's really quick. It already figured out or generated a dashboard for Iris. Well, let's in any case, let's just still take a peek at what the Iris data set looks like in the first place.
A little bigger.
I can't.
Okay.
So that's why I'm going to mainly use this one, because this is the biggest font one I have. Okay. So you can see that we have several different iris flowers. Each one has a label, right? Each data entity has a label. We're looking now at just 9 of them. I think there's maybe 152, 200 of them. And then they have a variety of attributes: sepal length, sepal width, petal width, species, right? Let's take a look at the second data set. This one is vehicle models. So every vehicle is associated with an entity label. Here I just decided to call it label 1, label 2, so on and so forth. You have the manufacturer, the model, the engine displacement, the year of manufacture, the number of cylinders for the engine, transmission type, et cetera, et cetera. So those are all the things that you have. That's the second data set. The third one is a little bit different, and now we're going to be looking at time series data of a variety of different sea creatures. So the sea creatures are data entities in this case, and you can see that we have however many that is, right? It looks like maybe, I don't know, roughly, well, let's call it 60 or so different sea creatures, right? Why don't we look at GRAMP, okay? I didn't make these names up, by the way. And you can see what GRAMP looks like. Okay, so again, you have the entity label. I didn't make that one up. It's GRAMP. You have the species. GRAMP is a sea lion. You have the time here, following the international standard format here of year, month, day. You have the latitude and the longitude. Okay. Someone added comments again. I just grabbed this off the internet, but you have also the gender, age, class, et cetera. But the main thing is, right, you have attributes like the time and the longitude of that and latitude of them. Right, now let's go and check back how Automaton is doing. Oh shoot, it's already done. So it ran through Iris. It generated a dashboard for it. It ran through the miles per gallon data, and it ran through the sea creature data. Let's see what it generated. Again, all this was generated just now on the fly. Okay, so let's look at iris flowers, okay? Here we have a nice HTML table, searchable, sortable, et cetera, just giving you a quick overview of what your data looks like, each separate data entity, okay? Now let's go to the chart below here. When you're doing analysis, it's typically, really helpful just right away to look at the correlation between all of the different variables. So that's what you have here, right? And you can see which variables recorded in are most correlated with other ones. It's also often useful to group data, right? In this case, we had three different species. Yes, species, right? Because these are all, I guess, subspecies or hybrids or whatever, right? So we had three different species. So why not group things by species, right? Right away, we can see that Virginicas have longer sepal lengths than the other species on average. What about like max petal length? Okay, cool. Virginica still. What about let's see, mean petal width? Okay, again, Virginica. So right away, I'm saying, hey, if I have a really beautiful iris flower, but it's small, and I want to try to hybridize it with another flower to maintain its beauty, but have a larger flower, I might want to consider hybriding it with a Virginica. Finally, it's often useful just to see a scatter charts of all the variables against one another, right? So that's just what this is showing here. So quickly you can see which variables are tightly correlated to which other variables, and rapidly. So this is the home page, or the landing view, I sometimes call it, right? Now, why don't we look at what I call the entity view? So let's just pick an iris flower, right? And let's see what it looks like in particular. Okay, so there are all of its different attributes, right, and their values, right? Here's how this flower, it's the one that's bigger, it's yellow, right? Compares to other ones across, again, grouped by species. Now, I will say the reason why you're seeing those sort of visualization artifacts, right, are because we're throwing a lot of electrons around, and we're running the browser from inside this Windows subsystem for Linux, rather than using this laptop's native browser. So if you were to launch this in a native browser, you wouldn't see those artifacts. Okay, it's just, again, there's a lot of moving parts in terms of virtualization here, right? Okay, so again, we have all those attributes now grouped by species, and we're comparing them to all the other flowers. Now you can see, sorry, at the bottom here, if I can scroll properly, the label will appear. There you go, right? So you can see how they compare across species. Okay, cool. So that was this specific flower. Now, what if we go to what I like to call the attribute view, right? Here we'll look at sepal length. Some people prefer histograms. Some people prefer CDFs. I like both. Some people prefer to look in terms of raw counts. Some people like to look in terms of percents. Again, I like both. So here you can easily, go between histograms, CDFs, counts, raw counts, or percents. That scatter chart that showed all of the relations on the landing view or the home view. That's a lot to look at, right? So here you can just compare this variable against any other variable, right? So we're on the scatter on the sepal length view. So let's compare sepal length across species. Let's compare it versus petal width, etc. Okay, and then why not, while we're at it, let's just go ahead and fit a regression model, right? So Automaton already did that. Here you have the output of that model. Down here you have a bunch of diagnostics, right? R squared, blah blah blah, and then here you have even more diagnostics. Looks like a reasonable model. And then finally, you have the footer down there. Okay. Cool. All right. Now this was a numerical attribute. What if we look at a categorical attribute like species? Same thing. We still have our histogram. To mix it up, we put it sideways to distinguish it from numerical variables. Same thing. You can look at species versus any of these other attributes. You can also fit a regression. Now we're looking at a multinomial regression in this case, which means that I can still show diagnostics, but there's not really any visualization to go along with it. But we still fit a regression. Okay, cool. So that I think that kind of runs us through the iris data set. Automaton also did this for the mile per gallon data set. Same story, right? I won't belabor this one for too long, right? But I will note that this time, there were more variables to group things by than just species, right? In this case, I can group things by manufacturer. I could group them by class. I could group them from year. I could group them at the same time simultaneously by all three, right? Which is what I have here, right? So same kind of charts as I was showing before, but now different groupings. Okay. Well, now let's just do it by manufacturer and class. Same thing. Okay, and this is all done inside of a pretty tight, easy to use run configuration syntax that I'll show in a few moments once we're done with this. Here I'm just doing it by manufacturer and year. Here I'm doing it by just manufacturer, and then here just by year, right? And so the whole idea is to see, which cars are most fuel efficient and how they've changed over time. And yet, man, this data set only includes vehicles manufactured in 1999 and 2008. So that's kind of, not very helpful for our purpose. Okay, now let's go and look at a specific entity. And again, I'm not going to belabor the point. I'm just going to show you that it has all the same things that we saw before, right? Now we're looking at this specific guy, which happens to be an Audi. But right away we can see that let's see, Toyota is this second to the right line here. Right away we can see if we're looking at city mileage, so that is really good. So is highway, same with highway, and so on and so forth. So right away, like if you're trying to buy a fuel efficient car, you might consider a Toyota, even though I'm not, like, don't get me wrong, I'm not like endorsing Toyota or anything like that. There's other good brands too. Okay, cool. Now let's go back to the attribute view again. All right, cool. Same kind of thing, So again, I won't belabor the point. This time, Automaton wasn't able to fit a model of this variable. It's really hard to fit a multinomial model when you have so many categorical factors. So that's why it failed, and it gives you a nice message indicating that, right? Okay, great. Now, the one thing I want to call out in particular is that now, even though this isn't a time series data per se, we still have what I'll call like a time-like variable, right? In particular, the manufacturer year, right? So as I already mentioned, we only have 2 years, right? Which is, kind of a flaw in this data set, if you will, right? Or at least a limitation of this data set. Okay, here we were able to fit a model successfully. Great, all the same diagnostics and stuff. But I wanted to show that it's often the case that even when you don't have time series data, you still have a time-like variable, and here we can provide a statistical treatment of that and some nice analysis artifacts, like again, like CDFs, right? So it's showing the ratio of vehicles that were built in 2000 or 1999 rather, here, and then the completion of that in 2008, meaning that we went from, for this curve here, 25% of the vehicles in this data set were built in 99. The other 75 were built in 2008. Now, if they were all built uniformly in time, that is, 5 in 1998, 5 in 1999, and so on, right? Then we would expect this chart to accumulate linearly, right? I'm doing the same repeating the same groupings, right? Again, well, no, actually, I'm sorry, I'm not. I'm only grouping it here by manufacturer and class, and then here just by manufacturer. So, we can provide a statistical treatment of that, right? In particular, we can do a Kolmogorov-Smirnov test to see, well, is this accumulation uniform in time? And more or less across the board, it says no. Kolmogorov-Smirnov is not necessarily the best or most powerful test for this purpose. You can also just look at, well, what's the mean, and then what's the deviation from the mean in the 1999 and 2008, and what's the probability value associated with that deviation, which is what's there in parentheses. Um, and and so on. And then finally, some people again like histograms. So I included histograms here. Okay, almost done. Let's go to the third data set. Right away, you're going to see that the dashboard takes on a different appearance. Some people like really light dashboards. Other people like dark dashboards. So hey, let's have some theming available that's controllable from the run configuration to allow users their choice of either light or dark, right? You might also notice that now, instead of having kind of how to put this, simple computer-like labels, right, for things, like if you look here, this data set, it's just called MPG, right? Now you'll notice that we have something kind of cooler, right? So we have, in particular, pretty names for all of the various attributes and data entities in the data set itself, right? I called it wild animals because it sounded cool, but also because if I also had like land mammals here, that's fine. Where you see sea creatures, you would also see an entry for land mammals. Okay, now other than that, kind of same story, right? All your data same way, grouped in this case by species and start year, or just by species. We'll go here. Let's look at a random blue shark. Okay, there again, all the attributes just like before, except now we have this new pane, if you will, right, which is going to show a geospatial display of this blue shark's path. Again, you're going to see some visualization artifacts just due to the fact that we're running this from a virtual environment. If you were using your machine's native browser, you wouldn't see those. But anyway, we can kind of fast forward. We could have custom text here at each data point if we wanted to. We could overlay things like weather, if like cloud cover in particular, if we wanted to. So the underlying technology here supports a variety of overlays and other things, right? Okay. You might want to look, well, what's the latitude and the longitude kind of as this path goes along. We could do that. We could add other charts in here too. Otherwise, same story. Looks like this blue shark. It's, if I recall, it's the area it covers. It's kind of on the low end compared to other blue sharks. Right. Okay. I think that's kind of it. I mean, we could go into maybe we'll look at one more time-like variable, right? In this case, start year, because we have a little bit better kind of distribution, if you will, or more variance, if you will. But otherwise, the same sort of stuff, right? Here you see the CDF, right? So you can see right away, well, most of the sea turtles were collected earlier on, whereas the blue sharks were collected later on. You can do the same kind of statistical test, and so on, right? Okay, cool. So now that's kind of the live demo. All three of those dashboards were generated from the data set in real time. Okay, those results did not exist. These dashboards didn't exist. I think Automaton might tell us how long it took. Well, more or less. We started at according to this machine's clock, at basically 12:57, and we finished at 1300. So it took 3 minutes to generate all of that using this machine's 16 CPU cores. Now let's just quickly run through the run configuration. Oops, sorry, I will use the one with the bigger text. What does this look like, right? Oh, Automaton also has the ability to plug directly or to connect directly with relational databases. So here it's basically saying, are you going to use a relational database like SQL or not? And I'm saying no, which is basically telling it to look at the local file system instead. It's asking how many cores do you want to run with. And believe it or not, when I launched this environment, that field had like a fake value in it, if you will. An Automaton determined on the fly how many CPU cores I have and put in that number. So if any of you are interested, when we install and run this on your own machines, right, Automaton's going to figure that out and just put the right number in for you. Okay. Here we're doing some theming. To be honest, this is kind of a little sloppy. I wanted to do the theming specifically for this demo, and I should probably go back and rewrite how it's done. But that'll be in a project for a future weekend. Okay, here I'm saying how I want to group things. Well, I'm sorry, I kind of went through. This is saying, hey, here's where you should look for the data. Here's where I want the output results written. Here's the variable that I want to group things by. If it's going to be helpful sometimes to make composite attributes, like again, taking ratios. If I wanted to apply any sort of mathematical function or even a custom algorithm, I could throw it in here, right? So I'm basically from within this simple configuration syntax saying, hey, do this kind of math, do this operation, right, to make this new attribute on the fly. And then here I'm saying, here's a variety of different summaries that I want generated. Again, this just kind of version control is telling you where to look for what file to look for, right? And I can go into the reason why I chose to stick with this name. But anyway, that's just kind of a design decision. Here again, I'm saying how do I want to group things, right? For these summaries in particular, and then what summary statistics do I want available for those groups? Do I want to generate? So again, sort of not really code. I would call this kind of like metacode in a way, saying on the fly how which summary statistics I want. Here I'm using simple things like mean, median, max, so on. But you could put in any operator that you want it to, right? Okay, cool. So that's for Iris. For MPG, basically the same thing, except now we're gonna group things in a more. We're gonna have a lot more grouping, right? So you can see here I'm saying, okay, well, I want to group things by manufacturer. I also want to group things simultaneously by manufacturer and class, and then so on and so forth, right? And then otherwise, it's basically the same, except I'm saying, hey, in this data set, I do have a time-like variable, and so here's how I want you to handle it, right? Okay, cool. And then for sea creatures, again, kind of same idea here. Now I have track variables, so I'm talking about that. Now I have these various attributes. Now I'm shifting a terminology a little bit and calling them nav attributes, since it's geospatial time series data that we're looking at, which I think we have some geospatial time series data in the Department of Defense, right? Okay, cool. Thought so. Okay, composite attributes, so on and so forth. So you get the idea, and now now again, I mentioned like pretty naming capabilities. So I'm even using like HTML tags inside of here to make things nice and clean. That's kind of the demo. Again, the idea is to generate really rapid analysis of any data set you might have, to plug it into this platform, get out the exploratory view of your data, including the automated generation of dashboards, all those analysis artifacts, and regression models. If you want to do more have them write more complex algorithms, right? You can inside of this framework. You can generate basically arbitrary analysis artifacts. This is I just kind of showed you the default analysis flow. But if you wanted to output JSON files, if you wanted to output other PNGs or movies or whatever the case may be, that's fine. You can do that within this tool, writing algorithms either with outside of our project or Python. And also the point was this was developed in support of an ongoing military mission to really get at high level effects for that mission. I can't talk about it here. If you want to talk about it with me at some other event, I'd be happy to identify that data set and that mission, and tell you in a little bit more detail how we were able to really arrive at statistically rigorous and still sort of holistic mission level effects for that operation. That's it. I'm happy to take any questions, hear any kind of ideas of how you think this platform could be useful for your mission, and otherwise, I think I want to then move into the sort of hands-on time for anyone who would like to get this going on their own machines. But that's Automaton. That's how it can rapidly analyze data sets.
You said it can be built into R and Python. Is it currently like connected to a package, or is it just like a separate program?
So yes, the question was, and thank you. The question was if this can be integrated into our project or any sort of R package, right? The answer is this platform is primarily written on top of our project, right? It's written on top of 5 or 6 different languages, depending on how you count, but primarily our project, and it uses probably over 100 different R packages. It is not a package in itself, nor would it be make sense to convert it into a package, because it does rely upon other languages as well. Okay, great. Right. Yes. At its core, it's a Unix command line utility. Okay. Any other questions, comments?
So just more generally, is it available for distribution, say on GitHub or other public?
Yes. Yeah. This is fully public. Yeah. So you can it's a link to download it is now in the abstract, right? Along with installation instructions. Again, at its core, it is a Linux command line utility at this phase in time. And so if you're a Windows user, the mechanism to install it on your Windows machine, like I did, is to first install Windows Subsystem for Linux version 2, which can be done with 1 or 2 commands. It's pretty straightforward. And then from there, you'll have the entire environment, because this is I wanted to package this and deliver it as a complete working environment. And so as soon as you load up this environment inside of Windows Subsystem for Linux, you're going to be granted or you're going to be greeted with that prompt, right? And it is for demo. So I would advise, once you actually move into using it on a more routine basis, then you probably don't want a demo environment that's going to bug you every time you open up a new window. Yeah. Mm-hmm.
So I'm curious about the run config setup. I want to make sure I understood. You have to write your own run config every time, and if so, is there any sort of utility that can examine your CSV, say, oh, these are all of the labels that were in there. Here are some defaults.
Right. So the answer is for each individual data set, you need to have a run configuration, right? So one run configuration per data set, right? Automaton, again, there had to be a lot of rigor in terms of design to enable this level of automation, right? So Automaton, when it looks at that data set, it is expecting each entity to have a field called entity underscore label, right? If you don't have that field, it's not going to run, right? And again, that's by design. Does that answer the question?
Yeah, I think so.
Okay. Any questions from our virtual audience? Okay. All right. Thanks.